Welcome everyone to BTT 151, Fundamentals of Electricity. I'd like to go over your Unit 10 homework. Question 1, how many degrees are the current and voltage out of phase with each other in a purely resistive circuit? 0 degrees. Question 2, how many degrees are the current and voltage out of phase with each other in a purely inductive circuit? 90 degrees. Question 3, to what is inductive reactance proportional? So recall the expression for inductive reactance, X sub L is equal to 2 times pi times the frequency times the value of the inductance. So 2 pi is a constant, that would be 3.14 times 2 or 6.28. So X sub L, the inductive reactance in units of ohms, would be directly proportional to the frequency in hertz and the value of inductance in henries. Question 4. An inductor is connected to a 240 volt 1000 hertz line. The circuit current is 0.6 amps. What is the inductance of the inductor? Like I've mentioned to you in past homeworks, always write down what is given. So the voltage is 240 volts, the frequency is 1000 hertz, the current is 0.6 amps, and we're being asked to find what the value of L, what the value of inductance is. So we can start with X sub L is equal to 2 times pi times the frequency times the value of the inductor. We're going to algebraically manipulate this expression. We want to solve for L. So L is going to be equal to X sub L divided by 2 pi over F. But X sub L is also equal to V divided by I. So we can substitute these variables in. So V divided by I, that whole expression will be divided by 2 pi times F. So now if we plug the numbers in, 240 divided by 0.6, that expression divided by 2 pi times 1000, final answer 0.0637 henries. Question 5. An inductor with an inductance of 3.6 Henry is connected to a 480 volt 60 hertz line. How much current will flow in this circuit? So if we write down what's given, value of the inductance is 3.6 Henry, voltage is 480 volts, frequency is 60 hertz, we're solving for the current. So again, our expression inductive reactance, X sub L, is equal to 2 pi times frequency times the value of inductive reactance, or times the value of reactance. Current I is equal to V divided by X sub L, the inductive reactance. So I can plug in for X sub L in the denominator, 2 pi FL. So now plugging numbers in, voltage is 480, 2 pi times the frequency of 60 hertz, times the value of the inductor, 3.6 henries, solving for the current, 0.353 amps. Question 6. If the frequency in question 5, the problem we just did, is reduced to 50 hertz, how much current will flow in the circuit? Using the same expression, voltage of 480 volts, 2 pi, this time the frequency has been reduced to 50 hertz, multiplied by the value of the inductor, 3.6 henries. Plug these guys in, we'll get a current of 0.424 amps. Question 7. An inductor has an inductive reactance of 250 ohms when connected to a 60 hertz line. What will be the inductive reactance if the inductor is connected to a 400 hertz line? X sub L is 250 ohms. The first frequency given, I'll call frequency 1, is 60 hertz. We're being asked to solve for what the value of inductive reactance would be at a second frequency of 400 hertz. So first I have to manipulate the original expression. X sub L is equal to 2 pi times F times L. Solve for the value of inductance. L is going to be equal to X sub L divided by 2 pi F. Plug the numbers in. 250 divided by 2 pi times 60 hertz will give me a value of 0.663 henries. Now I can take this value for the value of inductance and plug it into the expression with 400 hertz. So I designate this second inductive reactance as X sub L2 equal to 2 pi times the second frequency times the value of the inductor. Plug the numbers in. 2 pi times 400 times 0.663 will give us a new value of inductive reactance of 1666.3 ohms. Question 8. An electric heating element has a current draw of 12 amps when connected to a 240 volt AC line. What is the true power of this circuit? Remember that only resistive loads will dissipate energy. So if we solve for the actual power, question 8, power is equal to voltage times current. So 240 volts multiplied by 12 amps gives us a true power reading of 2880 watts. Question 9, reactive power is measured in what units? VARs, volt amperes reactive. And lastly, question 10, a pure inductive load has an inductive reactance of 8.4 ohms and is connected to a 480 volt AC line. What is the true power in watts produced in this circuit, and also how many VARs are produced in this circuit? So the problem tells us that it's a purely inductive circuit, so right away we know there is no power dissipated in a purely inductive circuit, so the power is going to be 0 watts. So we're going to be solving for the value of VARs, volt amperes reactive. And normally VARs are represented by the letter Q. So again, put down what was given. Inductive reactance is 8.4 ohms. Voltage is 480 volts. We want to solve for current. So the current I is going to be equal to V divided by X sub L. Plug the numbers in. 480 divided by 8.4 is going to give us 57.1 amps. So the final part of this calculation, we want to solve for the total number of VARs in the circuit. So I take the voltage V, 480, multiplied by the current we just calculated, 57.1 amps, will give us 27,408 VARs. Thank you.